So the next one I want to teach you is vector. Most people don't understand vector, but I've done videos on vector. We are going to, like, the major problem you're going to have in watching those videos is the visuals, because that time, as I've explained, tire. That time the camera I was using was not so good, so that's why it's blurry. But now, thank God, I'm using a better one. So let's talk about vector. But the thing is, if you follow those videos and you like plug in your earpiece, you listen to what I'm saying and you follow with your slide, you understand. But let me just brief you on things that I didn't teach in those videos. I'm going to teach it here. But make sure you watch those videos so you can understand what I'm saying. So in vector, what should I talk about? Okay, let me start with the definition of vector. A vector has both magnitude and direction. A scalar doesn't have direction, but it has magnitude. What do we call magnitude? This is what we call magnitude. Magnitude is just a value, and we represent magnitude by these two strokes. They are called magnitude. So you might not write magnitude, you might just write this. It's still called magnitude. So examples of vectors: we have displacement, we have velocity, we have acceleration. Example of scalars: we have work energy, power, and stuff like that. Anything field is vector. We have electric field, magnetic field is vector. Understand? Torque is also a vector. So a lot of examples of vector you should know, and a lot of examples of scalars you should also know. So there are some symbols you should also know. This is called magnitude. When you see something like this is called dot product or scalar product. It's also called dot product, scalar product. When you see something like this, it's called vector product or cross product. Vector or cross product. So don't get distracted. So you should also know this, that when we have A dot B, that's dot product. A dot B is equal to AB cos theta. So there are some questions they'll ask you that they'll give you, let's say A is equal to I plus 2J plus 3K, B is equal to I plus 5J plus 10K. They now say you should find the angle between those vectors. This is the formula you use. A dot B is equal to AB cos theta. If you're looking for angle, we are going to solve questions like that, so don't worry. But just keep that in mind. Know that A cross B is AB sine theta. You also know this too. What other thing? Okay, you should know that A dot B is also equal to B dot A. So you should also know that one too. So you should also know this one too. A dot B is equal to B dot A, because dot product is just the direct multiplication. But when you say A cross B is never equal to B cross A. A cross B is not equal to B cross A. However, okay, alright, stop. However, A cross B is minus B cross A. A cross B is minus B cross A, but A cross B is never B cross A. Understand? It's just like using the corkscrew principle. When you turn this way, it's going up, but when you turn this way, it's going down. So when you turn it this way, A cross B, it's as if the stuff is going up, but when you are turning it B cross A, going down. So that's how it is. So it's just the opposite. So A cross B is equal to minus B cross A. You should also know that these are things you need to know. You should know that I dot I, unit vector. Unit vector is I, J, K. where this represents x, this represents y, and this represents z axis. Understand? Just know. I'm just briefing everything for you, so you'll be able to catch. So those are unit vector. So they can give you a is equal to I dot 2j, I plus 2j plus 3k, and they say b is equal to 2i minus 3j plus 4k. Now they say, what is a dot b? What is a dot b? Very easy. Just multiply everything direct. I times 2i is 2. Why? Because I times I dot I is 1. J dot j is 1. K dot k is 1. But I dot j is 0. So you can never multiply I dot j because it gives 0. So, but here we are multiplying I dot I. So I times 2i is 2. 2j times 3j, that's minus 6. Y, this is plus 3 times 4, 12. K plus k, 1. K times k, sorry. 3 times 4 is 12. K times k is 1, that's plus 12. Then a dot b is minus 6 plus 12 is 6. 6 plus 2 is 8. So this is the answer. But what if they say, what is a cross b? What if they say, what is a cross b? You can't just give it the direct multiplication. That's when we go to matrix or matrices. There's also a video I've done on matrices, how to solve matrix. I clicked in one of my videos. Check these videos I've done how to solve matrix. So I'm not going to be solving matrix because I've done it before. You can just watch the video. So that's that on that. What else? Okay, so that's all. And there's this way, there's something you need to know. This one does not usually come down like that, but you just need to know how to. Since we know I dot I is equal to 1, j dot j is equal to 1. What of if they ask us what's I cross j? So that's when we go into this. We go I here, we go j here, and we go k. So let's say this j plus I. I've also done this one. It's in one of my short videos. But let's just go back to it. So if they ask you what's I cross j? What's I cross j? I don't know. So we follow this triangle vector stuff. I call it triangle vector method. So we are moving in the clockwise direction, just like this. So we ask you what's I cross j? You just go I cross j is equal to k. I cross j is equal to k. So that's k. So if you ask what j cross I? J cross I is equal to k, but it's not equal to k because you are moving against the arrow. So j cross I will be k, but that kind of k will be a negative k. You understand? Because you are moving against the normal pattern. The normal pattern is I cross j is equal to k, j cross k is equal to I, k cross I is equal to j. But they're not asking what's j cross I. So j cross I will be negative k. Now the next question said what's I cross k? So did I say dots? Sorry, not dots. I cross. So the next question is asking I cross k. I cross k. You are moving against the pattern still. So I cross k will be minus j. And what's k cross I? K cross I is now equal to j. So k cross I will be equal to j. So that's how to, if they ask you what I cross J, J cross I cross K. But I don't know, it doesn't usually comes out in test, but just know it. But it doesn't usually comes out in test like that. Of course, it's not your slide, so it doesn't usually come out in test. So you need to know matrix. There are other ways of solving that I cross J, where they'll say, when they give you the unit vector and say what's A plus B. But the fastest way is C matrix. Yeah, whether you like it or not, the fastest way is C matrix. So you just learn matrix. There's a video I've done, you can learn matrix. So is there anything else? I'm coming. So there's another thing you need to know, right? This vector multiplication stuff. Where they ask you, where there's a principle that says vector dot vector dot vector. So you know that vector dot scalar. Vector dot scalar will always give vector. Alright? Vector dot scalar will always give vector. But let's say vector multiplied by vector, it can give vector. And vector multiplied by vector can also give scalar. So there's this confusion when they ask you, let's say calculate work now. They now give you force is equal to I plus 2J plus 3K. Distances. They now ask you what's work. Let me explain that. Let me explain it very well. Know these principles actually. It helps. No vector dot scalar gives vector. Vector dot vector can give scalar. Vector dot vector gives vector. So if they ask, let's say they say force is 2I plus 3J and displacement is 3I plus 2J. And now ask you what is work. You know work is force times displacement, and force, as we all know, is a vector quantity, right? So if force is a vector, now do you know this, the s in the distance in work is not distance actually, it's displacement, because it's distance in the direction of the applied force. So that distance has a direction. So that distance is called, that distance is not distance, it's displacement, so it's also a vector. But now we are in a confusion of what are we going to use. Is it a vector product or a scalar product? Because here now we have vector dot vector, and we all know vector dot vector can either give vector or scalar. And if it gives vector, we are going to use vector product, not a scalar product. If it gives scalar, we'll use a scalar product, not a vector product. But here, what are we going to use? We don't know what we are going to use, right? Then we go back to the main formula. They ask us to look for work, and we all know work is equal to force times displacement. So since work is force times displacement, and work, we all know work is a scalar quantity, right? So since the result of force times displacement is giving us scalar, and we're going to use a scalar product. You understand? Like now, you know, we use vector dot vector, and vector dot vector can give either vector or scalar. But what this one is giving is work, and we all know constantly that work is scalar. It's a scalar quantity. So we are going to use a scalar product. So that will just be f dot s, and that will be 2I plus, that will be 6 plus 6, and that will give you 12 joule. You get? So let's say it's a vector dot vector. Let's say it's a vector quantity. Apart from work, let's say it's a vector quantity now, and they asked us to find the result. If the result is given vector, maybe which one can I use? Okay, yeah. Let's use torque. Now this one is for work. So work is f dot s. Let's use torque. So torque is force times perpendicular distance, right? Torque is perpendicular distance. Let's just write the normal way. Force times perpendicular distance, right? The perpendicular distance is actually a vector quantity without direction. First is a vector quantity, right? Because that's direction. So first is a vector quantity. So the two of them are vector. That's vector dot vector. So it can, it's also vector dot vector. It can actually give either vector or scalar. But since we all know torque is a vector quantity, understand? We all know it's something that you should know. Vector quantity and scalar quantity, something you should know. Since we know torque is a vector quantity, that's why we are going to use a vector product. It's unlike work now. Work is a scalar, so we use scalar product. But yeah, torque is a vector, so we use vector product. And you should know that this one, what is, I just represented this. The real one is actually torque is equal to R cross F. This one is actually wrong. This one is wrong. Torque is represented as R cross F. You understand? R cross F, and it's never. This is the correct one. F cross R is wrong. It's not this. It's actually R cross F. You should know that. So that's that and that. Nothing else. For resolution of vectors, I've uploaded 2 videos. Resolution of vectors using the geometrical method and using the analytical method. They are on my channel, you can watch it, and that will be all on vectors. I also solved 20 vector questions. I also uploaded a video on my channel. I've done that long while, so you can also watch that. And this video, so I'm going to be adding it into the playlist of my vector videos. So if you watch everything, you'll be fine. And make sure you like, make sure you subscribe and share. Thank you.